Okay, now we're going to move on to the second subtopic, which is integration by part. What does it mean by part? Is that you have integration of u dv equal to uv minus integration of v du. Okay, previously we have only u and du for the substitution technique, but now you have dv. So when we have dv, of course, we're going to find the v itself only. So now what we're going to do is we're going to choose u from here according to this order, so that it makes us easier to obtain the right hand side over here. So we choose u in this order. So how do I memorize, or how do I remember it, is using this short form, LOPET. So LOPET means logarithm, polynomial, exponential, and trigonometric. So we're going to choose u based on this order. Log, first log, second polynomial, third exponential, and the last one is trigonometrics. So this is going to help us to solve the integration easier. Let's see the example. Example 5, evaluate integration of x square root of x plus 1 dx. So what we're going to do first is that we refer back to the LOPET just now, the rules how to choose u. So from here we have x and square root x plus 1. So there are two choices we can make for u and dv dx. So first we let u equal to square root x plus 1. Okay, it's either you're going to choose u equal to x, or you're going to choose u as square root x plus 1. Now we try to choose u as x square root of x plus 1. Therefore, now you have this one. So you have this as u, and your dv will become x dx. The remainder, apa yang berbaki itu yang akan jadi dv. So kita dah ambil this one. Okay, let me pen. So we have this one as u. So the remainder ataupun baki dia, we have x and dx. So this one, x and dx, will become our dv. Why do we want to find dv? Because we have this formula just now, by part formula. Integration of u dv. So you have u and you have dv. Okay, when you have u, you're going to differentiate it, du over dx. We differentiate u with respect to x. So this part again, square root of x plus 1, we can also write it down as square root of x plus 1 is actually equal to x plus 1 to the power of 1 over 2. Okay, this is similar to this, square root x plus 1. So now you're going to differentiate this. Differentiate this, you get this one, this part. Okay, and then how about this? You have dv. When you have dv, you're going to find the v itself. So how do we find v from the dv? This is the differentiation. So kita patah balik, kita mau cari v saja. We're going to integrate it. So we integrate this part, integrate dv, you will get v. You integrate x, you get x squared over 2. From here, you're going to integrate it. Integrate dv equal to integration of x dx. Okay, so you integrate dv, you get this one. Get v. Integrate x, this one is x, okay, x, so you get x squared over 2. Okay, now we have a complete set of to fulfill this equation or this formula. You have u, you have dv. What else you need? You have v. Yes, we have v already over here. And you have du. Du is from here. So how do you find du? You just rearrange. Susun semula du equal to this dx. You're going to bring it on this side. Settle. And that is for u, dv, du, and v. So now you can integrate using the integration by part technique. We're going to rewrite this back. Tulis semula, rewrite this one. Equal to, follow this formula. Integration of u, this one is your u. This one is, the one I circle is your dv. Okay? Is your dv. So, we follow again to this formula equal to u, v. So, u, again, this is u. What is your v over here? This one. This is your v. This one is your v. V, okay? This is your v. This is u. Minus integration of v du. So, again, you have v. This one over, integration of v du. So du is this one. Since you have 1 over 2 and this one also 1 over 2, multiply, that's why we have 1 over 4 over here. So you can see that it's getting more complicated. Okay, you have square root over here and also you have power of negative half over here. We can't solve this one. We note that the problem is getting more complicated. Therefore, this choice of u and dv is not suitable. We can say that this is not the right thing to do. So we move on to the second option, which is previously for this one we use our u this part. So how about we change it? How about the second choice we're going to make? We choose x as the u. We try to make this one as a u. Let's see. So the second choice is that we're going to choose this as our u. And so the whole thing over here going to be our dv. Okay? The whole thing over here is going to be our dv. Over here. Okay, so u equal to x. So you have the remaining ataupun the baki-baki saki-baki dia yang tinggal akan jadi dv. Okay? So, dv. Yang baki itu adalah square root x plus 1 dx. So, previously dia adalah ada dx. So, since we want to find dv over dx, so you bawa pindahlah dx tu ke sini. Now you have u equal to x. Your u is simpler than the previous one. U equal to x. So we're going to differentiate du. Du over dx equal to 1. Now you have dv. dv over dx. This is dv over dx. This is the one, dv over dx. We have dv over dx. From this one, this is the differentiation. We want to return back. Kita mau patah balik to obtain v. So, apa kita buat? Bila kita dah ada differentiation, kita mau patah balik, kita integrate there. We integrate this part, so you get only v. And this one, again, this part is equal to, I think I mentioned this one many times. This is equal to 1 over 2. Square root tu punca kuasa bersamaan dengan kuasa 1 per 2. Okay. So, bila you integrate this part, both of this part, you're going to integrate this. Okay. So, you have this part. Okay. Now, you can use the by part technique. Okay. So, we follow this formula by part technique. Integration of u dv. So we have the whole thing over here. We write this thing and then equal to uv. Your u is x. This is your u. This is your u. And dv. What is your dv over here? dv is this whole thing, right? So you're going to bring dx on this side. So minus integration of v du. Integration of, you have your v over here, 2 over 3 over this one, times du. So du is this one. You can write it back as du equal to, when you bring the dx to the right hand side, you get du equal to dx. This one is your du. Okay, this is your v, and this whole thing is your dv. Okay, now you can expand the whole thing. So this one you're going to, this one you just rewrite, and this part you're going to expand lah. You integrate this part, so you get this, and then forget to plus c. Okay, so in 2 over 3 is constant, you just write it back constant. 3, when you differentiate, when you integrate this part, 3 over 2, so you're going to plus 1, ya kan, tambah 1. Tambah 1, so it become 5 over 2, or 5 over 2 lah. Tapi bila you bawa ke depan, dia akan jadi 2 over 5. This one is 5 over 2 bila you dah plus 1. Jangan lupa bahagikan dia dengan 5 over 2 lagi. That's why ni bila bawa dia jadi terbalik 2 over 5. Sebab sepatutnya dia dekat bawah, over. So you can expand this one until you get this. So this is by part technique. Okay. So if we compare this, our second choice, and the previous one, the first choice we make, this one is a bit more complicated. Since you have square root and you have over here power of negative, that's why when it's getting complicated, for sure your answer is wrong. It's supposed to be easier at the end. Okay, so that's why we choose u equal to x. Since these both, remember I said just now, we're going to choose u based on the law path: logarithm, polynomial, exponential, and trigonometric. So both x and square root x plus 1 is polynomial. So you have to decide which one. Next example, we have find integration of 3x exponent negative 2x plus 4 dx. So now we refer back, we're going to choose u now. So you refer back to the law path rules. This is polynomial. This is 3x is polynomial. Exponent ni until ni adalah exponential. This is exponential. This is polynomial. 3x is polynomial. So which one you going to choose as u? Kita tengok order ni, dia kata you choose, kalau ada log, you pilih log as your u. Tapi kalau tiada log, kita turun pula, kita pilih yang polynomial as your u. Since this one we have polynomial, so our u is this one lah, 3x. It become your u. And the second one, yang baki dia tu, yang ni akan jadi your dv dx. Kenapa dv over dx? Sebab we have this formula to fulfill. Integration of u dv. So this one become u, the rest will become dv. So yang sakit baki dia, eksponen negatif 2x plus 4 dx tu akan jadi dv. And then, inilah dia. Tapi kan sepatutnya dv tu, dx tu dekat sini kan? Tapi kita mau dia dalam sebutan dv over dx. That's why dx tu sepatutnya di sini kita bawa turun ke sebelah sini. So u equal to 3x. So now you have u equal to 3x. You're going to differentiate du over dx. Kita differentiate lah dia, dan kita dapat 3. And now you have yang sudah sedia differentiation. Kita integrate dia. Integrate this one, you get, integrate dv over dx, you get v. Integrate this part, you get e. Ini kita dah belajar last week. Integrate exponent negative 2x, you get exponent negative 2x plus 4. You get the whole thing itself, and then you divide by negative 2 over here. Okay, so complete. You have u, you have du, you have v, you have dv, right? So we can use this formula. So again, we rewrite this formula or this equation, integration of u dv. So previously your u equal to 3x, the rest ataupun dia punya saki-baki will become your dv. Kita just tulis balik this formula dari yang atas ni. Equal to, barulah kita substitute dia. uv, which one is your u? U is your 3x. That's why you have 3 and x over here. 3 and x over here. Your v is exponent yang inilah. That's why you have this one. This one is your v. This one is your v, kan? Dia ada per dekat situ. And then minus, kita follow balik this one, minus integration v, where is your v? This whole thing, you rewrite v du. So du, from here you have du equal to 3 dx. Kita bawa pindah dx ni ke sebelah sana. Tu yang dia dapat ni lah. Dia ada 3 and dx. 3 and dx tu adalah du. So, can you solve this? Yes, kan? So, kita tulis semula. Ini yang kita dapat tadi. You're going to expand it, you're going to solve this one. Ini kita just tulis semula. Why is it this one become plus? Because we have negative, and then over here also we have negative. So we have plus over here. Okay. And then you're going to integrate this. So integrate lah yang exponent tu dapat balik exponent, divide by negative 2. Darabkan lagi dengan 3 over 2 sebab dia memang asalnya ada 3 over negative 2 kan. Then you plus C. So kembang-kembangkan dia. Bukanlah kembang, you solve. You just rewrite it back. Cuma perlu kembangkan this one saja. So you get the answer. This is the integration by part technique. So I understand this one is a bit harder than the substitution method, the first one, because in substitution you only have u and du only. But in here you have 4. You're going to find what is your u, what is your dv, what is your v, what is your du. So you have to find 4 things over here. Your u, du, dv, and your v. So this is integration by part. Okay, let's see more example so you can understand better. Now find integration of x to the power of 4 ln x dx. Okay, to choose u, we need to follow this rule. Lopat again. So here you have 1. This one is one term, and this one is the second term. So which one? You're going to choose this or this? So we refer back. If we have log or ln, so this is going to be your u. And this is polynomial. Ini kan polynomial. Ini adalah polynomial. And ini adalah log. So of course we're going to choose this as our u. So ln x ni adalah kita punya u. Okay. So the remaining x to the power of 4 dx ni will become your dv. Saya bagi ni lah. become your dv. Dia akan jadi dv. X to the power of 4 dx adalah dv. Ni dia just bawa balik je. Asalnya dia macam ni. Asalnya dia dv adalah x to the power of 4 dx. From here kan yang saki-baki tu akan jadi dv. Tapi kita mau tulis dalam bentuk ni dv over dx. Jadi kita bawa lah dx tu ke sebelah kiri. Jadilah yang ini. So now you have you have dv over dx. What's next is you're going to integrate your u. Integrate u with respect to x, du dx. Integrate ln x, you're going to have 1 over x. And for this part, since there adalah differentiation, so we're going to cari dia punya integration. So kita integrate this. Integrate kiri dan kanan. So integrate dv over dx, you get only v. Integrate this part, x to the power of 4, you get x to the power of 5. Divide the new power, which is 5. Okay. Now, you have a complete set, u, du, dv, and v. Okay, let's substitute it into this formula, the by-part formula. Again, integration of u, dv, ni adalah yang ini, yang asal, equal to uv. So, your u is your ln x. We have over here, ln x is our u. And this whole thing over here is our v. Kan? Kita dah dapat v over here. Minus integration of v. Again, which one is your v? This is your v. This is your v. This is your v. And du. So, du adalah, ini bawa pindah ke sebelah. Jadi, 1 over x dx. This is your du. Sorry. Yes, du. Okay. So, next step is we're going to solve this part yang ada integration ni. Okay, kita tulis mula this one. We're going to solve this. This one, you just need to rewrite it back. And then for this one, you integrate x to the power of 5. Since this one, we have constant 1 over 5. Why 1 over 5? Why not we put it outside? 1 over 5 ni letak dekat luar siap-siap. So, you have x to the power of 4. Why is it x to the power of 4? Because dekat sini kita ada x to the power of 5 and over here bahagi dengan x. So x to the power of 5 divide by x to the power of 5 divide by x. So dia become x to the power of 4. Dia sudah kalau bahagi kan kita tolak satu. So tinggallah x to the power of 4 dx. So the only thing you need to solve is this part. Integrate x to the power of 4, you get x to the power of 5. Ni, you akan dapat x to the power of 5 over 5. Tapi kenapa dekat sini ada 25? Because we need to multiply x to the power of 5. 5 times 5, you get 25. Okay? And don't forget to put c over here. Okay, it's all done. Next example, find integration of x squared exponent x dx. So again, we're going to choose our u according to the law path rule. So x squared is polynomial. This one is polynomial. How do I write it? Polynomial. P, polynomial. And this one is integration. Sorry. And ex, not integration. Ex is exponential. So which one? Do we have log over here? No. Do we have polynomial? Yes. So, dia ikut urutan. Kita akan pilih mengikut urutan. We have polynomial and exponential. Of course, kita akan pilih yang polynomial terlebih dahulu as our u. Okay. So, the rest will become our dx. v. Okay, the rest will become our dv. Should I? This will become our dv. Okay, set u equal to x square and dv kita tu adalah exponent x dx. Okay, since we already have this one, tapi kita mau dalam bentuk ni, dv over dx. That's why this dx, you're going to bring it on this side. So you have only exponent x. So again, you're going to differentiate du over dx, you get 2x, and this one, we have a differentiation already. So you're going to integrate this both sides. Integrate dv over dx, you get v. Integrate exponent x, you get exponent x itself. So again, you have a complete set to fulfill this by part formula. You're going to rewrite this, the equation, equal to uv. Where is your u? Your u is x squared. This is u. And your dv. dv is exponent x over here. Our dv is exponent x. This is dv. I hope you can follow me. And then minus integration of v. So again, we're going to write v. This is your v. This is v. du. So du is, from here, you're going to have du equal to 2x dx, right? So the remaining 2x dx is your du. You just need to gather all these things into this formula. So because you already have the whole 4 terms, you just substitute it into this formula, by part formula. So you have this. But then, still we need to solve for this part. See, the blue box. Again, you have 2 terms in here. We need to do the by part technique again for the second time, because we have 2x ex dx. We have x is the polynomial and exponent x is exponential. So for this part alone, you're going to do the by part again. So ini adalah polynomial, ini adalah exponential. So kita akan pilih yang polynomial as our u equal to x, and sakibaki dia exponent x dx akan jadi our dv. Dia akan jadi, dia macam ni, dv equal to exponent x dx. Ni yang original. Bila kita susun balik, dia akan jadi macam ni lah. Susun balik, dia akan jadi macam ni. So you differentiate du over dx, you get 1. You integrate this whole thing, both sides, you get this. Integrate dv over dx, you get v. Integrate exponent x, you get exponent x. Therefore, we follow the formula, the previous formula, which is integration of u dv equal to uv. Is it right? uv minus integration of v du, right? The one in the yellow box. Yang ni. Kita tulis balik yang ni lah. Okay. So we have uv. Ganti masuk je. u and v. So you have x exponent x minus integration of x times dx. This is your dx kan? Your dx going du become dx tu bawa ke sebelah, dia akan jadi macam ni. Inilah. So, since this one cuma single term, so bolehlah kita solve kan. Yang tadi dia ada dua term, x and exponent x. That's why kita kena buat by part lagi sekali. Tapi yang ini tidak apa. Yang ni dah solve. Bukan solve. Yang ni dah almost, we almost there. Boleh buat sudah. So next, kita ambil semula yang the earliest question or equation. So we have this. This is the one we have done previously, yang kita buat by part lagi untuk kali keduanya. So we have this kan. Tadi kita dah solve, kita dapat ini sahaja. Jadi you're going to substitute lah dia. So you have integration. You integrate 2 ni kita letak siap-siap dekat depan. Integrate x, ex ni tulis balik lah yang the whole thing over here. Ni dia masukkan ke dalam sini. Exponent x times x minus integration of x dx. Maksudnya, the first time, this is the first time. Ini yang pertama kali you buat by part. And then, you dapat jawapan, you buat lagi. This is the second one. Yang you buat integration by part. So, now, ini ni boleh expand integration of exponent x. You get exponent x semula. Jangan lupa darabkan dengan 2. So, you get this. So, that's it for this question. Example 8 ni dia tough sikit sebab dia 2 kali kena do by part. So, I mark it over here. This is 2 kali buat integration by part. Next is example 9. Evaluate x, 3x dx. So, now you have x as the polynomial. 3x is the exponential term. This one is exponential kan, dia to the power. 3 ada power x. So we're going to choose u as x. This is our u. The remaining will be our dv. Ini akan jadi our dv. So again, you differentiate u with respect to x. You get 1 only kan. Kita buat macam ni, du over dx equal to 1. You dapat 1 sahaja. That's why dia bawa pindah ke sebelah, jadilah yang ini. And then dv adalah 3x dx. Kita punya dv adalah 3x to the power, 3x dx. So, kita mau dalam bentuk dv over dx, bawalah dia ke sebelah sini. And then you're going to integrate both part untuk dapatkan sebutan v. Kenapa mau dapat sebutan v? Sebab kita mau masukkan dia dalam this by part formula yang memerlukan kita cari v, du, dv, semua tu. So, again, kita tulis balik integration of u, dv. This is your u, this is your dv, equal to u, and this is your u. This is your v, kan? This whole thing is your v. This whole thing is your v. This is u. Let me erase it so that you won't get confused in the notes. This is u. Okay, and then you minus integration of v du. V, again, this is your v, the whole thing is your v, and this is your du. This is your du. This part, du. And again, you can integrate this part, and you get this. That's it. this is the final answer for example 9. Go to the last example, which is example 10. Find integration of 2 bracket 2 plus x square close bracket exponent x dx, meaning that you have the first function over here and the second function over here. So this is polynomial, this is polynomial, this is exponential, kan? Ini adalah exponential. So of course kita akan pilih U adalah yang polynomial. Ikut urutan polynomial dahulu. Kalau ada log atau ln, kita akan pilih log atau ln dahulu. So let U equal to 2 plus x square. And our dv yang sakit baki ni akan jadi kita punya dv. Bila kita susut semula, kita dapatlah yang ini kan? Macam tadi. dv equal to exponent x dx. So when you rearrange, you get this. And for u, don't forget to differentiate your u. You will get 2x. Differentiate 2, you got nothing. Differentiate x square, you get 2x. And for this dv dx, we want to find only v. So you're going to integrate both sides. Integrate, and then you get this. So we get a complete set, u, du, and you have dv and v. Okay, you can substitute it into this by part formula. So again, your u, this is your u, x, this is your v, minus integration of v. Again, this is your v, kan? This is your v. The rest is your du. 2x dx tu adalah du. Dia akan jadi macam ni tau. Du adalah 2x dx. So dapatlah yang ini. Ganti masuk dia. Du tu adalah 2x dx. Okay, now can we solve this one? Again, no, right? Because you have two terms or two functions, x and exponent x. So what we do here is, again, we're going to do by part, integration by part, because we have two terms over here. So again, I'm going to mark this example 10 as a special one because we do 2 times integration by part. So you don't have to include 2 because 2 is constant. We just write it as integration of x exponent x dx. Okay, so we have this. Again, you choose which one you're going to choose as your u. Of course, the x one because x is polynomial. So the rest will become your dv. Kan? Ni akan jadi your u, the rest will become your dv. So you dapatlah this part. Dan sekali lagi kita masukkan di dalam this by part formula. So you have exponent x minus integration of exponent x dx. So how about this? Can we solve this? Yes, because that's only one term, exponent x. Compared to the previous one, we have two terms, x and exponent x. Ada dua. So you cannot solve it directly. So now we write it again over here. Ini yang daripada yang awal-awal tadi, yang kita first integration by part. So yang ini yang kita solve untuk kali kedua. So bila you buat macam ni, ini yang kita baru dapat integration by part yang kedua. So it's over here. Kita gantilah. Ganti masuk yang ini, kita dah solve, dia jadi macam ni kan. Then you just need to kembang-kembangkan dia. 2 times x ex, 2 times, dapatlah ini. 2 times integration of exponent x, you dapat exponent x. Then kembang-kembangkanlah yang ni, you just expand and then you get the final answer. Okay, so this is integration by part. We have two example, which is example 8 and 10, where we use 2 times of integration by part. Okay, and then when do you need to do 2 times integration by part is when you have the answer in this term. Ada dua. Satu ada X, ada exponent X lagi. So nampak sangatlah dia kena buat lagi sekali. Kalau macam ni sekali saja tidak perlu. Ni you can just integrate straight away, you can integrate it. Okay, that's all for integration by part. So we have covered 2 subtopic. The first one is how to integrate using the substitution method, which is using u and du. And the second part is using integration by part. So yeah, in integration by part, you have to choose your u according to the log-pad rules over here. If there is log or ln, you choose that log or ln as your u. If there is no log or ln, then you check whether there is polynomial or exponential, or the last one is the trigonometric. Okay, so these are some of the exercises, so please try it on your own and check back your answer over here. That's all for this week. Thank you.